Hello. Today we're going to continue our conversation around dilation, especially its connection to scale factors. And so the vocabulary that we'll frequent today will be scale factor, dilation, theorem, parallel lines, corresponding angles, and ratio. And just as a reminder, theorem is basically a statement that has to have proof to it. And so as we're looking at this, the dilation theorem, I tried to highlight some of the important parts, but a dilation centered at O, with a scale factor of R, that creates the transformation of dilation, sends P, which is the pre-image, to the image P prime, Q, which is the pre-image, to the image Q. And then we have this formula that the result is equal to the scale factor times the original. And eventually we come down to the ability to write this out in fraction form. And essentially, you might want to turn this into words, but the way I look at it is that I have the image divided by the pre-image that equals my scale factor. And then you start thinking about the scale factors. What happens if it's equal to 1? What happens if it's greater than 1? And what happens if it's between 0 and 1? And you had a little quick write in class today about that. And so the video is really how can we utilize this and use it to verify or prove things. And so the first problem says produce a scale drawing with M as the center. And that is an important part, knowing that you have a center and what your scale factor is, which is R, of 3/2. And so as you're going through this, there are different ways to create a dilation. We've done the ratio method. You've also seen me work with the compass to also produce exactly points that I need. First thing I need to do is extend the lines radiating or emanating from point M. I thought we'd look at how you could potentially use your compass. This isn't like a traditional way necessarily, but how could I use the compass to be able to even do something like this? So the first thing I do is I need to find that midpoint. And once I have that midpoint, I can scale out my drawing from there. And so I'm slightly off, I can tell. A little human error. And so here we are. And how do I use that for this? If I want to do 3/2, well, there is half of my line segment right here. And then I would just use, there's 2/2, it brings me out to L, and then there's 3/2. And so right here is the spot where I would put L prime. Okay, and I can do the same exact thing for M to N. So draw an arc. You don't want to lose these skills as you go through the course. That way you just don't have to remember them or review them. They're just kind of always there. And so here's the midpoint. Get my arc, make sure it hits on that midpoint just right. So compass needs to come out just a little bit. And then I can do the point from N out. And so here's N prime. Oop, let my ruler move. Don't want to do that. All right. And so it says use the theorem to predict the distance of Ln. So let's just even get the measurement of the original, which looks to me to be about 5.6. It's a little heavy. And so then I would take 5.6 and I multiply it by the scale factor, which is 3/2. And when I do that, if I'm going to use my calculator, probably easiest if I have it in decimals. I get 8.4. And now let's verify whether I did this correctly. And as you can see, 0 and 8.4. And so that's how you can utilize the dilation theorem. Does it appear to hold true? It does appear to hold true because, and this is where you want to really add and solidify your explanation, and that's one of the areas of growth that we have for each other. Because R times L M equals L prime M, R times M N equals M N prime, and the last one that we worked on, R times Ln equals L prime N prime. And that's an important piece that it didn't matter which one I was working with, but the scale factor times the original brought about the distance of the image. And so you can keep going. It says produce a scale drawing with X as the center, so I like to kind of circle that using the scale factor 1/4. Use the dilation to predict the distance of Y prime, Z prime. So what they mean by that is I'm going to look at this. This is approximate 3.2 centimeters. If I take 1/4 of that, it should be 8/10. So I really should turn my ruler around. Mark it at 8/10. Come over here. It's really close to 5.5 centimeters, so 1/4 of 5.5 centimeters. It would have been better if it was 56 because that'd be 1.4. So essentially it's 1.4 centimeters with a little underneath it. So here's 1.4 with a little bit underneath. To be truthful, the pencil or ink thickness is probably going to eliminate any of that. And this one, just double checking my measurements. Make sure I did not. So sometimes you have to use your eyes. I definitely marked that incorrectly, and so it really should have been here. So this should be Y prime, this should be Z prime. So if you're ever doing construction in your future, the measure twice, cut once statement, really a good rule to abide by, because you don't want to have to make a mistake ruining your project. All right. And so this is 8/10 This is 1.4 roughly. And so I have a distance of y to z of 5.6. And so my hope is 5.6 times 1/4, or 5.6 times 0.25. This should give me 1.4. And as we measure this, this is the verification of it. You can see now I've got the right distance here, that it hits right there at 1 4/10. Okay.